Whenever you're watching a live concert, or some breaking news, or even just your favorite creator streaming online, you're really witnessing this incredibly complex chain of technology. It all has to work together perfectly. But right at the very beginning of that chain, there's this unsung hero, this foundational piece of tech that gets the whole thing started. So today, we're going to pull back the curtain on that unseen workhorse, the protocol known as RTMP. So let's just jump right in. Have you ever really thought about it? How does that signal from a camera in, say, a stadium or a studio make that amazing journey all the way across the internet to your phone, your laptop, your TV, and all in just a few seconds? It really feels like magic, doesn't it? But it's all about having the right protocols. And here's the really surprising part. The protocol that still kicks off most professional streams today was actually created for a totally different era of the internet. We're talking about a time dominated by Adobe Flash, way before the first iPhone was even a thing. And that protocol is RTMP, which stands for Real-Time Messaging Protocol. Now, its job is super specific, but it's absolutely critical. It handles what we in the industry call the first mile of a stream's journey. Basically, it's all about getting the video reliably from the creator's encoder, that's your software like OBS or maybe a hardware camera, over to the cloud streaming platform. So how does this first mile journey actually work? I mean, what is RTMP really doing behind the scenes to get your stream up and running? Well, it happens in 4 key steps. First, your camera feed gets encoded, which just means it's compressed. Then that data gets packetized. And you can think of this like breaking a huge file into thousands of tiny little digital envelopes. Each one is ready to be sent across the internet. And this is where RTMP steps in. It transports those packets, basically pushing them over a super stable connection to the streaming platform, which then ingests or receives them on the other side. And this visual just illustrates that whole process perfectly. Over on the left, you've got your source, your software, or your camera, and RTMP is that reliable highway that pushes all those little data packets over to the cloud platform on the right. It's a direct, stable, point-to-point connection designed to do one thing and one thing only: get that stream ingested without a single hiccup. Okay, but if RTMP is so great at what it does, why don't we use it for everything? Why is it just the first mile? Well, that's because the internet went through this massive shift that totally changed how we all watch video. Back in the early 2000s, RTMP and Flash, they were a package deal. RTMP sent the stream, and the Flash player in your browser played it. Simple. But then, in 2007, the iPhone showed up, and famously, it did not support Flash. This was a huge deal, a seismic event in the tech world. It pushed Apple to create HLS, or HTTP live streaming, a whole new protocol designed for streaming to its devices. Fast forward to 2020, Flash was officially gone, and the entire playback game had changed forever. Now, what's really fascinating about this slide is what didn't change. Just look at that top row, Ingest protocol. Back in the Flash days, it was RTMP. And today, in our modern HTML5 world, it's still RTMP. The huge takeaway here is that we completely swapped out the playback part. We went from RTMP and Flash Player to modern protocols like HLS and the HTML5 video player that's in every browser. But that first mile, it stayed exactly the same. And that really brings us to the core question, doesn't it? In this world of cutting-edge, next-gen streaming tech, why does this old protocol from the Flash era still dominate the single most critical part of the entire process? I mean, I know what you're probably thinking. With Flash totally out of the picture, it seems a little strange, right? So why do professionals still trust this legacy protocol to get their streams started? The answer really boils down to 3 huge strengths. First up, compatibility. RTMP is everywhere. It's universally supported. Pretty much every single piece of encoding hardware and software you can buy speaks RTMP. Second, it is incredibly reliable. It's built on a foundation that has built-in error checking, which makes sure all those video packets arrive in the right order. It was designed from day one for a stable, continuous connection, which is exactly what you want for a live broadcast. And finally, it's just simple. Setting up an RTMP stream is really straightforward, and that makes it accessible for everyone, from total beginners to seasoned pros. But of course, it's not perfect. Its latency, the delay, while pretty low, isn't real-time like WebRTC, which is designed for things like video calls. Its history with Flash can sometimes cause a little confusion. And here's the big one. Modern web browsers just can't play an RTMP stream directly. It has to be converted into a different format for playback. And that's exactly why its role has become so focused, so specialized. Okay, so let's put all these pieces together. Let's see what a complete professional streaming workflow looks like today, with RTMP playing its vital part right at the start. This right here is the modern pipeline. It all starts with the creator, it goes through a sophisticated cloud platform, and it ends with the viewer, wherever they are. And RTMP is the bridge that connects that first absolutely crucial step. So let's walk through how this all works. It kicks off with RTMP ingest, just like we've been talking about. Your encoder sends that single, stable stream to a platform like Dacast. Then comes cloud transcoding. Now this is a really important step, where the platform takes your one stream and makes multiple copies at different quality levels, 1080p, 720p, 480p, you name it. And why do that? For the next step, global delivery. Using modern protocols like HLS, the platform can automatically send the best quality stream for each viewer's specific internet connection. This is the magic that stops buffering. And finally, it all lands as HTML5 playback, which just means it plays beautifully on any device anywhere in the world. So the bottom line is this. Modern streaming is all about using the right tool for the right job. RTMP is still the undisputed king of ingest. HLS and Dash are the standards for delivering to a massive audience. And yeah, newer protocols are out there, SRT for when you have a bad network connection, and WebRTC for super interactive stuff. They all have their own specific vital roles to play. This quote just says it all, doesn't it? You might not be watching video using RTMP anymore, but it is absolutely still the most reliable, most universal starting point for pretty much every professional live stream happening right now. It really is the starting line for the race. And that kind of leaves us with one final thought. RTMP has been unbelievably resilient. But technology never ever stands still. New protocols like SRT are definitely gaining ground, especially for tricky network conditions. So the big question is, what comes next? What's going to be the next universal standard for that all-important first mile of live video? Well, only time is going to tell.